She yelled in my ear a little too loud. All right. So yeah, so we're going over section 5. So the section 5, I think it's labeled as data cleaning with Pandas or something along those lines. I lose track of what the names are and stuff like that, but that's what we'll talk about today. So we'll kind of talk a little bit about Pandas. So at this point within section 5, you've seen a lot of Python. You have your environment set up. You should now have like NumPy, a little familiarity, and then Pandas. And like I mentioned last time, NumPy, or sorry, Pandas data frames and series are really built around NumPy. So you'll see a lot of similarity between those two, which also means that we have a lot of like, what's it called, speed that's enabled within NumPy itself, or not NumPy, within Pandas. And it's because of the way it's structured and stuff like that. If you guys are curious, we can talk about that another time. I have a really great resource on that too that I should probably share out to you all. That I think, well, I guess it's the book, but it's all free online, like HTML. So I'll talk about that another time. So while I get this kind of started, Pandas is going to be like our kind of go-to as a data scientist. What we'll do a lot of times with Pandas is basically we'll test things out. Now, I will first say is that Pandas does have some limitations to it, which we'll talk about much later in the course. I think closer to like module maybe 4, maybe I think actually module 5 is when we'll actually talk about this. And we'll talk about distributed networks in parallel. But Pandas is kind of like your data scientist home. Like it's kind of like, this is when you take in your data, you test things out, see how they work. And you can do most data, I'm not saying, I don't know if most is the right word, but you can do a lot of data science going through and everything. Rebecca, okay, thank you, Rebecca, for letting me know. Oh, wait, she's gone. Okay. No, she's still here. Okay. So just know that Pandas basically is kind of like, there's not the only tool, but it's going to be your most used tool. And so we're going to use pretty much the whole course that we're going through. Okay. So it's really important for you to actually go through this. Now, when working through data, I'm going to go start sharing my screen. Where are we? There we are. Cool. I think that's the right screen, right? Yes. Okay. And I can't find you all. Where did you? There you, you guys were hiding from me. Okay. Zoom moves around in my windows all the time. All right. So basically, the first thing we're going to talk about is just how we're going to work with data in general. My gosh, why is... Sorry, everyone. I know you guys can't see my windows moving around, but I keep clicking on things and it's moving my windows around in a weird way. Okay. So quick thing is there's a resource. This is actually within the... What's it called? And I'll send this out to you guys right now. There's a resource in the student resources spreadsheet that one of the instructors, Eli, had put together. So he actually, let's see here. I'll get it. Links over. Oh, is this the right one? Yeah, I was right here. So if you click on here, it's a Google Drive. It has a few resources for Pandas. I highly recommend it. An instructor, Eli, put it together. But here's basically a couple of cheat sheets on like how to deal with Pandas and like how to do certain things. So for example, being able to plot directly with Pandas, which is super useful. You don't necessarily have to go into Matplotlib. This is useful like when we have to say, hey, like, let's just go print this out for myself, not for other people. Like when you're not communicating things, you're just kind of like exploring parts. And then I think, you can't see this too well, but this basically has a bunch of little like idioms and stuff that you would use over and over in Pandas for grouping data, indexing, dates, stuff like that. And note that you don't have to like memorize this. Like this is not something you have to like say, oh, I'm not a real data scientist unless I memorize this stuff. A lot of these things, the stuff you use over and over again, you'll end up remembering and just being aware what's possible. For example, you can do pivot tables. Is anyone familiar with pivot tables from Excel and stuff like that? And those people who gave thumbs up and thumbs down, how well is your understanding on pivot tables? Because usually people are like, I can do pivot tables. I don't know what's going on with pivot tables. Yeah, that's usually what I hear. And so, but pivot tables aren't actually that bad when you think about it. They're really confusing why they're called pivot tables, I think, for most people. But if you're familiar with that, you can actually do that within Pandas itself with a data frame, because Pandas data frames really are just spreadsheets. And so it's an important kind of like concept to know. So I think most people have some experience with Excel, is that if you think of like Excel and spreadsheets and think of like that as data frames, it's a lot easier to think like, oh, cool, like that's kind of how it works. The difference is that Pandas actually makes very structured aspects of it, where each column has to be a specific data type. Excel, you can put whatever you want in there, and Excel doesn't really care. But with that structure, it means that you can do a lot more automated stuff and a lot more useful things in exploration where you have large amounts of data. Okay. But anyway, this is that resource cheat sheets here. Get to know Pandas. Feel free to, for example, always like Google things. Like there's no shame in Google. It definitely helps you out and everything. Cool. So let's go into some actual coding stuff like this. So with Pandas, and this is kind of like a little mix of like section 4 into like section 5, just so you guys kind of know. The first thing to do is actually loading in data. So there's a few ways you can do this. We can read a CSV, so we can always do pd.read CSV. That's usually what you will see when you're playing around with little files and stuff like this. And CSVs can be very, very small, or they can be very, very large, right? So it's always being aware of like, what you're reading in. And it's important to know that Pandas, the way it works, it'll read it in as a full into memory. So if you have a 12 gigabyte CSV file, note that it's going to try to read that 12 gigabyte CSV file into your computer. If your computer only has 8 gigs of memory, your computer might not do too well. Now, if you're using a big data science computer, like, like desktop, those can have like between like 64 to 128 gigabytes. So you can do a lot of stuff within Pandas if you have the memory for it. But just kind of be aware of this. Other ways you can do this is actually loading in data sets. sklearn, which we'll see a lot of, it's a great machine learning package. So you'll see us import this. You can actually load certain data sets that are built into sklearn. And this is actually really great for like testing out things because they're relatively small, they're well known. You can just literally search like sklearn, diabetes, for example, and you'll find this like page right here that shows about this data set. There's 442 samples, dimensionality, meaning there's 10 different columns. You can see that basically the ranges from -2 to 0.2, they're real numbers, and then the actually targets and stuff. So this gives you some quick information, and these are useful data sets to just load in very quickly. So you don't have to like, if you just want to try things out or play around with your algorithms stuff. But we're gonna use that so we can explore it.
Victor, sklearn are data sets that already exist. Then, and you're just like saying to load in diabetes, which is one of the data sets that exists.
That's right. Yeah. Okay. So this is basically just loading in the data set itself. So you'll see here, the way I should explain this is that load diabetes is a function or a method that basically does the whole process of, sklearn's already installed. Let me load in the data into a data frame for you. So you don't have to like, well, I should say the data is a data frame, but it loads the data with extra stuff. So you'll see here when I run this, it's really a method. So if I go ahead and actually do like type of, say, load diabetes, you'll see that's a function, right? So you can see it's like, okay, it's a certain type of function. You can see me actually load this. When I load in the data, and this is basically in a special format. I don't actually remember what it's called it actually returns, but it'll return a special format, and we can actually get the data that we want to use and actually get put in there. I think, now I'm curious, sorry. Lauren, you got me, you nerd-snacked me. I want to know now. So let's see if we just type data. See that? So, okay, so they have a special type here. This is bunch. And you'll see these things happen over and over. You'll get used to seeing weird things that you've never seen before, and that's perfectly fine. What is nice is the documentation basically says, okay, we can just get the data directly from here and feed it into a Pandas data frame, which is something we're more familiar with versus a bunch here, which might have some extra properties and such. So I'm just going to load it into our data frame. So hopefully you guys will be familiar with loading, basically creating data frames from many different ways. One, like I said, is read CSV. You can even read Excel files. So if you have an Excel file, you can actually read Excel and read it into a data frame as well. And another way is basically more a brute force, is to do data frame and feed into direct data. So if I wanted to be more pedantic in here, I could have been like data equals data.data, which I don't know, kind of extract it out. But you don't have to necessarily have that because it's the first parameter in here, right? But basically for a data frame, you might feed in data, and then in this case, I'm actually feeding specific column names. So this will actually give me the features name. So it'll tell me each column. If I didn't put in column names, well, let's see what happens. I'll do column names here, and now I can do a df head, and you can see I have all my data here. Well, there's only the first 5 rows, right? And as well as the column names themselves. If I didn't put these column names in here, does anyone know what would happen?
What did you say? It'll display without the column names, I guess.
Yeah, you're good. Sorry, I saw 3 different mics go off too. So it's okay. Yeah, so we'll see that, and basically it just numbers them off. So it'll still display, and basically it'll just automatically give that 0, 1, 2, 3, 4, 5. So if we actually want the column names, which is probably what we want to know, for better reference, right, we'd actually keep this in here so we can reference them a lot easier. Cool. Any questions?
I got a question about the syntax with the in number 9 there. So data, is that, do we have to put our variables names twice, or is one of those supposed to be data and it just so happens because it says data since our variable is data?
Yeah, it's kind of confusing because it's mostly the name on here. There's a lot of data going on here, right? So this first data equals, I know you didn't ask about this one specifically, but there's just a name parameter. So if I do a shift tab here, you see that basically it says data, index, columns. These are our named parameters. So you can pass them in by name. You can even like move them in different like order as long as you name them. So that's our first part. So this is actually not needed. I could get rid of this. But like you were talking about, Melvin, is the data part, like what's going on, right? And data, the first part is actually coming from here. So if I actually rename this, I could have been like, let's see, diabetes data. I could have named it like this. And so you'll see, for example, this is now something called a sklearn bunch. I don't really, to be quite honest, I don't really know what that is. But you could do some research, like you can do a Google and say, oh, sklearn bunch, they have some certain properties. It's probably a way they package information for different parts. So now what I can do is if I do just like, let's just print out what this diabetes data is, and you can see here, oh, okay, it's a dictionary, turns out. So you can see here, here's the data itself, and this gets all the stuff. Here's the target, and there's probably some other stuff here too. Looks like description. Oh, that's pretty cool. I know that. So, so for example, it looks like I can probably do, I'm guessing keys because it's a dictionary. Cool. So you can see here, there's different keys. There's data, target, description, feature names, data file name, target file name. So some basically metadata about this stuff. So really what I want the data, right? So I say, well, I just want basically all those columns parts. I can do .data. And you can see I get basically a bunch of NumPy arrays where each of these are a column. So this is one column right here. This is another column right here. And you'll see this dot dot. It means there's a whole bunch of stuff that we haven't listed. We could also do like, let's say dot description. Was it descript? Yeah, so you can see here, this also now is just a string of a description of the data itself. So this is how you kind of like, if you see something new, you can kind of explore it a little bit and see what's going on. But that's what this dot data is. It's just referencing one part of this dictionary, essentially, this, this bunch, which is diabetes data. So I could now replace this, for example, with diabetes data, and this will get the featured names, which we see if I do a feature names. Oops. You can see I get all these feature names, which are basically just all the column names. So cool. Does that clear things up, Melvin? Give me a thumbs up for this.
Oh yeah, I was just confused because, you know, the name itself was
data. There's a lot of and this is where sometimes, you know, it might make more sense to be a little more, you know, you'll see me tend to do things a little more like longer and kind of long-winded, but sometimes it helps with readability versus like, what's this data? Because that could mean a lot of different things. So anyway, cool. So we got our data loaded in. We now have a data frame, and now we got to do some stuff with it. So what some interesting things we can do are things like with lambda functions. And so this is kind of more of a side, but I'm kind of bring it up a little bit, is with lambda functions, basically they're short little functions. So if I wanted to write a function called double, so I wanted it to basically double whatever I put in. So like, for example, I put in some number x and return basically x times 2, right? Okay, that seems pretty easy. So now I can do double 2, that'll give me 4. If I do double, I don't know, 10, right? Gives me 20. If I do 10.2, 20.4, you guys get the point. And kind of quick check is, what would happen if I put the letter A in here? You got to guess.
AA.
A, right? Cool. So, and then similar, if I actually did a list, 1, 2, it would double that list twice, right? So remember, that's different. Remember also if I do np dot, I actually don't know if I imported a NumPy yet. I'll go import that right now. So I'm kind of just showing you guys some extra code just as we go through. But I could also do like 1, 2, or 12, why not? You can see here that will actually multiply by 2 because it's basically just calling and replacing whatever's in here with that. So this is kind of nice. Like, okay, that's why functions are useful. But this is a really short function. And this is where basically like, it's like, well, we want to save some space, but also another reason why you might want to write little short functions, we'll call these like anonymous functions. is you don't really need to give it a name. You're going to use it just once for the specific set of code. And so you'll use a lambda function. There's another subtle reason why you want to use lambda functions over just a normal function, is that when you write this, basically you have to write the definition and then later on call it like further in. But if we had like other code, like a bunch of code going through and then wrote double, we'd have to go and there was some weird mistake. Like let's say, for example, we did something like, I don't know, let's say we did divide by 2 by accident. We meant to do times 2. We'd have to go find where this function double occurred and go all the way up. Lambda functions allow you to write it basically right next to the code that you're changing. So it's a lot easier to debug and stuff like this. So lambda basically takes in a parameter like this and basically says, all right, take in your parameter and return basically this part. So takes in a value and then returns this part. So this is literally the same thing as our double function. And you can see we can do some other things too. You can actually save it as a variable. So if I wanted to do like times 2, what I can do here, I'll say, okay, what it's going to do is going to take one parameter, and return x times 2. So you can now see double me will actually return 4. And this will also work the same way as we showed with just a and stuff like that. So it works exactly the same thing. This is how you can give a name. You can also do things where you have 2 parameters or more than 2 parameters. X comma y here basically says, all right, you're going to take an x, you're going to take a y, and let's just do x plus y. Okay, so it's going to add them together. So this lambda x comma y, basically this function now is looking for 2 parts coming through, and it'll do x plus y. So now we can actually do this part. This should give us 6, and you can see it gives us fine. This is honestly, usually you wouldn't do it this way. I'm just showing this for demonstrative purposes. Usually you'd have something like a map, which is what we'll show right here. Okay, but does everyone follow me with these lambda functions so far? Thumbs up if it sounds good. Cool. All right, I'm seeing some thumbs up. Awesome. So this is how you can do stuff. One thing to note, you can technically give as many variables as you want, right? Like, I mean, you get to give different names, but like you can do as many as you want. I probably would say if it's more than 2, you might want to consider just making a regular function, because then if it gets too long and cumbersome and stuff like this, and note that you can only do 1-line stuff. You can only do that. You can't do it the next line over. So these are for like relatively simple functions. If you have a much more complicated function, it makes sense to do it a def, you know, the classic way of defining functions. Again, your goal is readability. So you want to balance what's the right thing to do. Okay.
Is there a computational resource advantage to doing a lambda function versus a regular function, or is that just so negligible?
Yeah, no, it really is like the same thing. You could argue maybe like storing the function, but because lambda functions are so small, it doesn't really matter. They both get called in the same way. So there's nothing particularly different. The only difference is that once lambda is done, it just throws it away and the resource is empty. But it's like you said, it's so negligible. Like I won't even like worry about it.
Okay, so the main goal is of learning lambda functions and inventing them is purely just readability at this point.
Readability, and it just makes them like a little easier to debug and stuff like that. Okay. So you'll kind of see a little bit of example. Good question. Cool. So,
what exactly do you mean throw away?
I'm sorry?
What do you exactly mean by throws it away?
So once I run this guy, for example, how do I call him anymore? Unless I gave him a name, like I saved him, it basically doesn't, there's no reference to him anymore. So basically it means that the computer is kind of like, when a computer creates like a variable, a function, whatever it does, it has to save it, what we call in its memory space. It's a little computer sciencey for us, but it saves it in the memory space and says, all right, this is where this function exists. But if there is no reference to this function, like later on, there's no way to call it. Python does something, this is again getting more technical, computer sciencey, has something called garbage collection. And basically it makes sure that if things aren't being referenced, it says, oh, okay, we have this written down, we stored it, but no one's referencing it anymore, we can write over it. And so it can save space in that way. But it's usually so small, it's not a big deal. So when I say throwaway, you should really think like anonymous functions. So if you want to like search for like what is a lambda function, search anonymous functions like Python, and that'll give you a lot more detail. And my little kind of like shortcut thing, throwaway, is that basically it's like, oh, it's not needed after it's used. Okay, cool. All right. Yeah, good question. Yeah, always call me on something like if I say something and it doesn't quite make sense or you're not sure what that means, definitely call me on that. Okay, cool. So now we can actually use it for mapping. This is how you normally would use it. So we can see here, for example, we have our series here, okay, our age, right? And so if I list this now, you'll see a series, right? Which remember, think series, whenever you think Pandas series, think NumPy array. Okay, so that's really what this is. And so basically it's an array of all these numbers, right? And so what we can do, for example, is I can apply a function to this series to basically like apply this function over and over again. So for example, if I wanted to do like, we had the double, I can actually pass it in like this, and this will actually double each value. So you can see here, it actually doubles each part. So you can see here, this very first one is doubled this part, and this one right here is doubled after that, and so on. If you did like the math and everything, but trust me, it's doubled. Okay, so we'd have to write a function up there, but you imagine like writing this part right here, like, okay, double, and let's say it was like, oh wait, is that what I'm supposed to do? I have to go find where the definition of double is, be like, okay, and see, oh wait, no, it's not quite right. Okay, I need to change it up and everything, right? So you can see here that it might not be right. So one thing we can do is write the function directly in here. And this map function, this dot map, says, all right, take each aspect of the series. So it's going to take each number and say, apply the function to this guy right here. So this is really useful. We're like, okay, we can actually just take this number, apply it, basically do some machine operation on it, and output that part and save that. So you can see here, for example, my result, I can say, all right, take each number. So take this number first, times it by 1,000, right? Times by 1,000 and return that. So now what happens is I can take this function right here, and you can see here, it worked exactly in the same way how double worked, is that it just took that number through and applied that function on each individual part. Okay, does that make sense to everyone? Cool. So this is also really useful if you already had a function defined. So let's say I wanted to do like double, like I wanted to apply the double function and then times by 1,000. Well, one thing I could do, well, the problem is like I couldn't write this directly. I could, for example, do like double x like this. And so let's say there's already a function that exists. Oops, I should actually spell it right. Wait, did I spell it right? Yeah, wait, there we go. Wow. I need more coffee today. All right, so we have double here. So if you have a function that already does something, you can actually apply that function and then do something else to it to make it your lambda function. But this is also really useful if you have something that's like a 2-parameter function. So for example, let's say we had add me, right? So let's say I had add me. Well, I couldn't just pass add me here, right? So remember add me as I defined it up here is adding 2 numbers. If I try running this, it'll give me an error. It says, oh, oh wait, again, I have to actually spell it right. You can see here it gives me a type error. It says, hey, you didn't pass enough parameters in there. It's missing one required parameter. So it's like, well, I want to add just an extra like 1 to it or something like that, right? Well, what I could do is actually create a lambda function like this guy and say, all right, take in 1 value, which again be just the value from the series. I can say add me, and let's say I want to add like 100 to it versus just 10. But now I can basically take add me and say, okay, take the value here and add 100. Now these are really simple functions, but you can see if a function was really, really complicated, you could just basically hijack that function, make it into a one-time function and everything like that. And now we can see it gets added every time. Okay, cool. Any questions on this mapping part? And this is something you'll probably see very often, especially if you're trying to do for missing values. You might want to apply a certain thing or a certain transformation to it. Cool. All right. So last thing is we can actually do conditionals with our mapping. So I think I actually didn't show this part. Oh, I must have deleted it by accident. Okay, we'll do it on the fly. So one thing we can do is actually do conditionals with our mapping itself. So let's say if we have, for example, I'll do .age, so it's a little bit easier for me to write, .map. And let's say if it's greater than 1, if it's greater than 0, I want to times it by 100. If it's less than 1, let's say I want to just make it 0. So I want 2 different things. So I can actually do this with lambda. So remember I do lambda x, so it's going to take each part in that, what's it, in age, so these parts right here. Oh, I should probably just get rid of this part so it's a little easier for us to read. There you go. So you can see each part in here, okay? And I want to say, okay, if that value is greater than 0, let's just add 10 to it, okay? So I would do something like, okay, x plus 10, right? Well, the problem with this—
typo there.
Oh, do I have
The map.
Oh,
Yeah,
thank
right
you.
there. Yeah.
I want to see that right away. Thank you. Okay, so I could just do it this part, but then this won't work for if it's less than 10, right? If it's like, oh, well, or less than 0, it's not going to work. So what I can do is like, okay, x plus 10 if x is greater than 0. Okay. Otherwise, else. Okay. Let's do just set it to 0. Else just save it as 0. So what this is going to do, it's going to take our value x and say, all right, is x greater than 0? Yes, it's greater than 0, add 10 to it. If it's not greater than 0, 0 or less than, we're just going to return 0. So this will basically make all our negatives 0, and all our values that are greater than 0, our positive values, will be added 10 to it. So you can see here, that's what happens here. So this can be really useful doing stuff. And I could also have done something like, let's say like x times, just to make it really clear. And you can see I could do different operations and stuff. And so this allows us to do some conditional parts in here. And this will happen a lot where you're like, oh, for example, you want to change the value to something else. This is when you would use these conditional parts in here. Okay. Any questions on how this works?
I have a quick question.
Mm-hmm.
So in the line above that, you had df age with the brackets, and underneath you just had it with like the dots. Does it matter which way you do it? Is there like a preferred version?
Yeah, you'll see me do this when it's like I'm being lazy. This is kind of like you can reference it directly. However, this won't work if I have, let's say, I'm just going to make a new column here. So I can make a new column, for example, new column equals, I'm just going to just literally copy what's here, right? And then I'll do a df.head. So you can see here there's a new column right here. Well, if there's a space in there, I can't just do new column, obviously, right? Because there's a big space there. However, I could put in the brackets itself and do that within quotes. There's not really a way. Some people might say, oh, maybe I can do it this way. It's not going to work. So this is only useful when it's like a nice formatted, which is why we tend to use underscores. Because if I did instead an underscore instead of a space, then at least then I could put an underscore here. Oops. And that would work fine. Honestly, the better way is probably this way because this will work every single time. This might not work depending what kind of column you have. Okay. Cool. No, good question. And that's why I like to show you guys different parts, so that way you guys are familiar when you see it. Cool. All right. So here's another example where I have basically sex, where it's like sex is, I think it's 0 or 1, right? What's here? Oh, you can see here. Basically, this is already like standardized. So you can see 1 is like above 0 and 1's less than 0. Basically, just a way to encode this information. I can say, well, I want to do this as male and female. I'm just going to say this is male, for example. I think I said that was what this is. So, okay, I take each value. I say it's female if x is less than 0. So basically, negative values are supposed to be female. Otherwise, it should be male. So if it's greater than 0 or greater than. And you can see now if I actually write, oops, well, I already changed it. That's why it's giving me an error. But if I do dia.sex now, you'll now see it says male and female and everything. So it makes it a lot easier for us to deal with. Okay, and so this is how you can change things out as you need them. Cool. All right, so I'll lead to aggregations. So I'm going to tell you a little bit. There is some parts in combining data frames. I'm going to kind of skip part of that because we'll touch again on that when we talk about SQL. But I'll just go through it really briefly. So one thing I can do is do different aggregations. So for example, I can give the BMI, which remember this will just give us a series. So this BMI will just be a series. And I can also display a few things. So for example, I can display how many there are, what's the minimum. So you can see there's 442 values, which makes sense, hopefully, because 442 values in this whole thing. And you can see basically the minimums. Okay, get the minimum here. I can also display the maximum. So these are aggregating all of them together. You can also group it by sex. So this would basically group it by sex, so male and female. So there's only 2 different values, right? And this will group it together. And then it'll say, okay, let me look at BMI. So this will actually return now a grouped, what's it called? A grouped data frame. So you can see here, male and female are now the index here. And you can see it's actually grouping each part and it's getting the maximum. I could have also done something like the sum, which wouldn't make sense in this case, but you could technically do this. So basically summing up all the female and males. So if you had something like, let's say, click versus the view, you might group it by click view and then say, oh, all the clicks, the number of times it clicks, and so on. So you can do basically these aggregation parts. You can also get it so it's just the BMI. So you can see here if I do just BMI, which would be if I did, let's say, so yeah, if I did this part, you can see here what they're split up, male and female, and you see it grouped by sex. So you can see how many times this happens. And I want to see how many times BMI happens. I can do a count. I can also do like, let's say mean. So I can see what's the average between male and female for these 2 different groups. And I get these parts in here. You could also do that for age. I think age is going to be a little bit harder to read because it's already standardized, but you can see here, I can have all these different ages because there's a lot more ages. But you can see what they're split up into and everything like that. Cool. All right, any questions on aggregations? All right, hope that makes sense. And you can also aggregate multiple parts. So you can see here, I'm grouping it by sex and BP, so your blood pressure, right? And you can see here now it goes by sex, and then for each female, they have a different blood pressure. So there's many, many different blood pressures you can have. And then for male, you can have many, many different blood pressures. So you basically, each row now is representing gender and the blood pressure. This probably would make more sense if I actually did age, right? Because then it would be like, oh, okay, what your age is, and then your male. So like that way I can split the group and stuff and order those parts. And I can do the normal operations just like I did up here. Okay, cool. Everyone follow me so far?
I had a quick question real quick.
Yeah, go ahead.
I know you said we're going to get more into this when we go over SQL, but is there any way we can sort by age to get like a sort by ascending or descending?
Yeah, you definitely could. This would make more, I think that's what it does by default. It actually sorts the age. So you can see here, it's a little harder to see, but you can start the smallest value to the largest value. But there are ways you can sort it. For example, you can go into, yeah, I'd have to look it up to be quite honest. But you can do like, for example, sorts and like sort it on a specific column and such. And that can be useful if you like want to like have it. But I think by default, it goes alphabetically or numerically smallest to biggest. So you can see that's why female pops up first and then male, because female comes before male. Cool. All right. Awesome. And also know that when you do kind of do some sorting, you can actually define the way you sort it, which again is a little more advanced move and stuff like that, but you could do it. The last thing I'm going to show you is that sometimes you'll get data that looks like this and you're like, cool. It's like, but I didn't mean to do that, or oops, like I need to unstack this. So unstacking is kind of like when you have, like you can see here, the way it's structured, you can see it's stacked because there's literally like a stack on top of it. We can actually undo this part. So we can split this up. So like, well, I don't want male and female. Maybe I want to split those up again, or male, female, and age. Maybe I want to split it up again. So for example, I have here sex and blood pressure. I'm going to do age because that's a little bit easier for us to understand. So you can see here, that's our stacked part, right? So here's my group. It's like, well, let's say I want to get rid of basically the male female part. I just want it by age. I can now unstack it. And now you can see is that we actually have it just like, okay, this is going to be male female, where we actually have, it's kind of like a pivot table in that way, is that we have each part is its male female. So now I just have just the column straight down, basically just females, just male for each individual column. So this can be useful if you want to split up in a certain way. There's a whole bunch of ways you can do it. Personally, I don't tend to use this method. I usually would just like do the, filtering within the data frame and get those parts. But if you're looking at it over and over again, sometimes this makes more sense and will save you more time. So then there's a bunch of options you can do. Okay, cool. All right, and then last thing, I'll just mention it very quickly. We'll go over this, more, especially in SQL, but basically there's different joins you can do: an outer join, an inner join, a left join, right join. Thumbs up if anyone does have SQL experience. All right, see a couple thumbs up. Some kind of like, okay. SQL is definitely really a useful tool to use as a data scientist, but we'll go over more into, I think, module 2. For the most part, at least for the first project, you won't have to be doing joins and stuff like that. It's not going to be a necessary thing. But if you have multiple resources, you might join data frames together. Okay, cool. Yeah, so any questions in general about anything I've kind of shown in this past like half hour? Sound good to everyone? Thumbs up? Sideways for like, okay, mostly seeing some thumbs up. Okay, some nods. Okay, cool. All right. So let's move on to our exploring data. So this is a little more about like, what happens when you have missing data and stuff like this. Well, the only way you're gonna know it's missing data is you gotta explore it. And we'll do a lot of exploring as data scientists. I think usually it's quoted, and I'm gonna make up some numbers because like, I don't know, it's always just a high number. It's like 80% of your time as a data scientist is cleaning and exploring data. That is just a true fact of life. Even when you get the cleanest data possible, there's still going to be things like, well, I need it to be this way. Kaggle, for example, a thumbs up. I think everyone's familiar with Kaggle, kaggle.com, right? Okay. Someone, okay. So Kaggle actually has like these competitions. They also have data sets, which I actually was going to show you. So I'm actually going to take this up real quick. Kaggle.com. So Kaggle, it's owned by Google, just so you know. But it's a really great resource. It's basically a lot of collection of data science, machine learning. It's most famous for competitions where you can compete to try to make predictions and actually earn money. So you can actually win money and stuff like that, like sometimes thousands of dollars. Some people actually make quite a lot of money off this. But besides that point, if you're not big on competitions or you're like, I'm not skilled enough, you can always check out their database or data sets. And their data sets are really cool because there's a lot of interesting data that's actually found in Kaggle.com. A lot of them can be done as companies already collect this together and shared it out. Other people might actually like collect and web scrape data and put it into here. And so this is actually a really great first going through, like when you guys get into projects where you guys will need your data set, this is a great way to search and see what's in here. For example, you can see 20,000 data sets, which is pretty good. What's also really nice is that a lot of times they're very, very clean. So even with it being clean, there's still going to be data cleaning that you have to do. But Kaggle's kind of like a little more, cleaned up. So it's always important to know how to explore your data and go through it all. Okay, so we're actually going to go through this. We have our Titanic CSV, which if I go into, I'm not going to show you all. You guys get the point. It's a CSV. It's got some info in it. So I guess actually I can show you guys this way. So remember, I can call a command line stuff. So as if I'm in the terminal, I can just do head, let's say Titanic, data / Titanic. And you can see here, this is the actual raw output. So this is as if I typed it in the current terminal. So for example, if I just do, you can see here, this is where I am right now in my terminal. And this is the actual first 10 lines of the CSV file. So you can see here, we got passenger ID, survive, P-class, name, and all that stuff. Okay, so we're actually going to read this as a CSV. You will be very familiar with this CSV. Note that there are like literally like 20 options for like this read CSV. You can do a lot of different things. Okay, but we're just going to simply read it through, and you'll see basically this first column right here is an unnamed column. Basically, it's empty. You can kind of see where that came from. There's nothing here. So basically, Pandas says, I don't know what that is, but it's some column. It's probably the ID, for example, just like to say what column number it is. And you can see here there's a passenger ID, survived. Let me make this a little bit bigger. Where's my, oh, see, I messed up my window earlier, so I'm kind of, there he is. Oh no. Why are you doing this to me, Jupiter? All right, well, trust me, there's more on the side. Is there more? I don't know. Oh, maybe not. Never mind. That's the last of it. Marked. I thought it was bigger. So the different columns and stuff like this. You can see it's different variety. So a quick thing that we should do whenever we get a data set is just say what's in it. Always do head. Like always check it out. Like that's probably like my first go-to, just to get a feel for like what's in here already. This is only the first 5 lines, so you might miss some details, but you might see some immediate things like, oh, this is supposed to be a string right here. Looks like there can be multiple people, or oh no, this is like their first name, last name. You can see there's like some question marks here. Maybe there are multiple people. So I kind of look at that a little bit closer. Like, okay. You can see the male, female. You can see the age. It looks like SIP. This is where, for example, you might actually look at like the dictionary of like what this is. So if you're given data from a business, it's good to ask them, hey, what are these column names and stuff like that? It'd be really useful to know that stuff. If not, sometimes you can kind of figure parts of it out, but it's useful to actually look up and say, where does this come from? Because maybe fare, for example, might be discounted fare versus like just the regular fare or something like that. You can also see, for example, this fare 71.28333, which is kind of like, why is it like, you know, like if you're using US dollars, usually you don't pay in 0.33 cents. So this maybe this adjusted, you know, from like modern day from the Titanic and stuff like that. So these are things that you would want to look up and stuff. So that's like, I haven't done anything other than just look at the first 5 columns, and I can already see like a little bit of information about this. That's why it's always important to do this. Okay. So next part is like the .info, and this is a nice little like summarized version. So you can see here is that .info is really nice. Is that it gives you basically how many entries there are. You can see the full Pandas data frame will have 891 entries. You're like, okay, cool. You can see unnamed here. It's going to be interpreted as an int64, which basically integer 64 bits, basically just an integer. And so basically there's some numbers here. So that's probably makes sense. That's basically just what's it called? I'm missing my name. Your ID and stuff like this, basically numbered each part. And then you see the passenger ID itself, so you can see the similar kind of thing. in 64, P class. So you see this P class here is this object. So whenever you see object as the type for a data frame, basically that's a string. So you can see here this P class, which is this guy right here. You can see this looks like it should be a number though, right? So what's probably happening, because Pandas has to have the same type all the way through the column, there might be something in here that isn't an integer. So maybe there's, for example, I'm just give you a hint. I think it's a question mark or something, or someone put a letter, or someone types in the number O-N-E, 1. This happens all the time with dirty data. So this is always really important to see, oh, that's what these types are. Name, sex, age. You can see age here. There's some missing values in here. So we can see age. It should be a float 64. So it looks like there's like maybe someone's 22.1. We'd have to check that out and make sure that's legit. But also you can see there's a lot of missing values here. So that's a really nice thing, right, that we can see immediately. And then we can see the rest of these. It looks like most of them have non-missing values, except for this one. Only 204 of like the nearly 900 people have missing values, are not missing values. So this might be something like that's a big or a lot of missing values. This might be a candidate for us to drop the whole column. This also might be a candidate for us to say, hey, maybe there's a reason why they're null values. Maybe there's something going on here. Does anyone got a guess for the Titanic data, why there's so many people without like a cabin as like a null value? Or
is it because they're crew members?
Yeah, probably maybe because they're crew. Like this is where like domain knowledge might be useful and say, okay, like maybe that's why it's missing there. Maybe it's because they didn't really keep track of the crew. This is where it's important to like realize these parts before you just start dropping data because it has missing values. Remember, data is valuable, but also you don't want to get bad data too. So missing values are kind of like this weird part where is it actually valuable or is it not valuable? Okay, so from .info and .head, we got a lot of information about this data set, right? And we can kind of see a few things. So next part, df.describe, which is really nice. There's a lot of summary on things that are already integer. So for example, we won't have this P class is put as an object, so we won't actually have that. You can see there is no P class because it's only looking at integers and floats, all numerics and stuff like this. So you can see all the different counts. For age, for example, we can see there's missing values. We can see the mean, standard deviation, 25, 50, 75%. Those are basically your quartile ranges. So basically 25% of people, or let's say of these rows, 25% are at least 20 years old, 20.125. So that means there's 25% of the list in here is less than this age. And then same thing happens with 50. Basically 50% are above, 50% are below. 75% means that there's 75% of them are below at this age or below, and 25% are above this age. And then see the maximum value is 80 years old here. So this is right here. If you were their IQR, our inner quartile range, this is our inner quartile range, 21.25 to 38.0. So that would be our middle 50%, sometimes it's called. So you can see some really quickly stuff. You can see a lot very quickly is that most people, more than 50% of, like 75% of the population in this Titanic database or this data frame is 38 years old. So there's very few old people, right? That's going to be a very quick change. So another thing we can do real quickly is df.valueCounts. So this basically can show us, like, for example, this specific column and say, okay, for this specific column, how many people are P class 3, P class 1, P class 2, question mark. So that's why I was reading it as a string. Basically, question mark isn't a number. So it basically just listed as 49, something like this. So this might be something where, well, we might have to go back to this. Can we actually assign it a number? Is it not known? Does it make sense for us to drop this? These are the different things we can do. In this case, we might actually end up dropping it because there's a relatively small amount. But maybe if your data is really valuable, you might want to just put this with someone. This is kind of like always the question about what you do with missing data. Okay, and you can see survive.unique. Say, well, okay, survived. You can see it looks like 0 and 1, right? So we can actually check out a unique, and you can say, oh, okay, yeah, there's 0 and 1 here. So that means all different unique values. You can also do this with like something like age. So you can see here is that you see, for example, we have some missing values, right? And you can see all these different parts. And you can see, for example, there's some decimal 0.92, which is kind of interesting. Like, like 0.92, I might just estimate that up to like 1. So it looks like most people, like for example, 0.83. So maybe that's something useful. Maybe it's not. Maybe depending on what you're looking at, it just all depends on what you want to change and clean up. Okay, so you can already see with just like these like few commands, we actually learned a lot about our data so far. And so there's one part in here that I don't actually recall if the what's it called, the curriculum goes through. And I think we'll talk about this data visualization for tomorrow, but I'll give you guys a little hint right now. Usually what we'll do is do something like a histogram. So for example, if I do like df dot, I'll do the proper way, age, right? I might do like a hist. So this will actually create a histogram. Oh, I didn't do the matplotlib though. There we go. If you don't do inline, it'll get to run it twice. But you can see here the distribution, and it makes a quick, dirty graph. This is a graph that you probably wouldn't show to like business stakeholders, but you can use it to like guide your own probability. And you can see here, that makes sense. We saw most people were under 38, and you can see there's very few. This drops off very quickly. You can also see that there's a huge like spike here, and then a drop off at the younger people. And that probably, hopefully that makes sense. Has anyone got an idea why in the Titanic, like why there's this huge difference between young people and then all of a sudden like looks like 20-year-olds?
Probably because 18, you can legally buy a ticket.
I'm sorry. I think Lauren and Devin said at the same time. Lauren, you want to go ahead?
Oh, I was just saying, like, adults and children, like, kids have their parents there, and then, yeah, a teenager would probably buy a ticket by themselves.
Yeah, there's probably a few people who are just kids. It's mostly probably kids with adults, and then they're just adults. So it probably makes sense there's a huge jump and stuff. So again, this is already telling us a story just by doing a histogram. You will hear me again and again say, do visualizations. We as humans do a really good job at taking visualizations and internalizing this information. That's just the way we evolved. That's how like a big part of our brain is for visualizations. So I always say like graph it out because it's always like this right here is hard for me to like comprehend and say what exactly is going on here, right? This is just a list of all the numbers, but here it's a lot quicker to actually see all different parts. I could have also done like value counts to kind of like emphasize. See, it's gonna take a while because it's gonna go through. You can see I could technically do it this way and kind of see like from the different ages, like all the different parts, but it's a lot harder for me to understand exactly like what's going on here versus a histogram where I can visually see that. Okay, so these are kind of the ways you would initially explore. Any questions on any of the stuff I kind of showed or anything like that?
Kind of going along with a message that Lewis just posted on the group chat. So the describe method, now does it take into account like the missing values? Like would the missing values kind of skew like say the mean where you have the would it do like the sum? Would it do like the number of passengers in the in the denominator? Would that be like total amount of passengers in the data set, or would that be just the ones with actual values?
Okay, and you're talking about this describe part, right?
Yeah.
Yeah, it would only count the ones that are not missing. So that's a good point to emphasize is that it's not gonna it's not changing. It's not doing stuff for you. It's like, oh, null values are 0 or whatever. This is just based off of the things that are not null values. Cool, good job. And thank you for pointing out. I didn't realize there's questions in the chat too. Sorry. If you guys ever need to interrupt me. So let's hear. Lewis says, isn't it better to do descriptives after dealing with missing values? Actually, Lewis, I would say doing a descriptive like describe or anything like this is actually useful to do before and afterwards because you want to know where your plans of attack, especially if there's a lot of different columns. This is like 10 columns. Like you could have easily something like 40, 50 columns sometimes on certain data sets. And to go through it like individually, this gives you a very quick plan of attack. Okay, so I suggest always doing this before you do anything with the data. Okay, and then Jeffrey had a question. Each kid would have 2 parents, so the number of adults would be more than double the number of kids. Yeah, so good. Sorry, I missed those little chats and stuff like that. So thank you for, so cool. I'm actually gonna close it so I can actually see it pop up. All right, so missing data. So one thing I'm gonna suggest to you guys, because I can only go so much, is Jeff, one of the instructors, is actually within the student resources. It's actually in version 1, but a lot of the version 1 stuff that you guys will see, we're on version 2. But a lot of the stuff in version 1 curriculum is really relevant. But I'm gonna send that off to you guys. He does a really great job of doing a walkthrough of like, going through finding missing data and stuff like this and all that stuff. So missing values, as you guys probably guess, what's the issue with missing values? What are some potential issues we have?
Well, if you have a lot of missing values in you may render that specific column irrelevant. If you have obviously too much missing data, the data set may not, be useful to provide.
Yeah. No, thank you. That's a good point. Is that basically if you're missing data and like this column, like a lot of it, it might not be useful. Like it might be hard for us to actually like get information out of it. There's other things too. Like there's a whole bunch. Go ahead.
Couldn't it potentially cause a problem when you're trying to iterate through certain columns?
That's right. So if I tried to, for example, applying a transformation, some mathematical transformation on the numerical value, but it's a missing value, I might get an error depending how that function's written. Or the other part is if I pass that information, so let's say another machine learning algorithm, for example, we'll talk about linear regression later this week. Linear regression, you're not going to have, like you're not going to be able to perform that machine learning algorithm because it can't handle those missing values. It doesn't know what to do with them. Should it ignore it? Should it treat it as zero? Should it do something else? This is where like you basically want to make sure things are prepped and cleaned. Really, you don't want missing values. If there are missing values, there's one solution you can do, like the most like brute force is literally just make it a string and say missing or something like that. At least then you know it's missing values, but it will be something you can process through. That's one way the curriculum talks about it. But there's other ways we can deal with it too. So there's a few ways. One is, and I realize we're kind of like got 7 minutes left, so I'll go through this a little quickly. This is mostly iterated from the curriculum. But the first one is just we remove it, right? We basically just drop the columns. So you can actually have a drop specific columns. Note that this drop, I don't believe it goes in place. So note that basically a good way to do this, so you'll see in the actual resource here, in place equals false. In place, you'll see this a lot with most data frames operations for data frames in Pandas, is in place basically means it does it right then. So if I do drop like in place, it would drop it and I don't have to recall it. What we'll tend to do as data scientists is that when we actually write this code, we'll actually do something closer to df, let's say like new is equal to df.drop. I'll just say like columns equals, this is not a real data frame, so that's why I'm just making something up. It's like column A. So this right here will basically take whatever this would be. It takes the data frame df, drops column A, and then stores into df new. If I did just this, and then did a df.head, the column would not be removed. Basically, this is to kind of make sure you don't accidentally drop things or make changes to your data frame by accident, because it's harder to go back. So imagine if you're going like, 100 lines into this stuff, and then all of a sudden you do a drop, like, oh shoot, you can't just undo it. You have to go all the way back and restart the whole process. So it's kind of like an extra check, and usually that's a good place. So you can circumvent this to actually make it work in place, and a lot of functions will have in place equals true, and that will drop in there. I suggest not using this as much as possible, just because it can lead to a lot of accidents, basically, especially if you're used to doing it over and over again. It's perfectly safe. You'll see people use it, but I tend not to use it because I try not to do the bad thing, like even when it doesn't really matter, because then you get used to doing the bad thing, and then it's just really easy to mess up when it actually does matter. Okay. So something I just wanted to add in there. But one way, just remove it. We just get rid of it. So that could just be literally dropping the whole row. Like Lewis had mentioned, maybe that whole data is just like that column, so it's completely useless. Like that cabin, like only 200 of like 900 is actually listed in there. It might make more sense maybe just to drop that, depending on my situation or my context of what I'm trying to look for. The other thing is we can do is just drop specific rows. So maybe there's a row that not just has one missing value in like that column, but maybe it has a bunch of missing values. So maybe they don't know any information about this person, this passenger that was on the Titanic. I might just drop that person out because there's not enough information for me to like gather from there. I could technically try filling it out, but if I start filling it out, I'm basically making a person that doesn't really exist. I really don't have enough information. So this is where we drop it stuff. So you can actually do a df.drop NA, and this will drop all the rows with this. You could also do a .drop and actually use rows specifically. Again, I'm going to point you off to this part where you can kind of see.
I have a question.
Mm-hmm.
Actually, is there a technique here on dropping I guess all of this information, like whatever way we gather it, let's say from surveys or whatever, if we determine if there's a lot of missing values, people just, I guess, didn't answer the questions, right? Is there a tool here on dropping rows or columns that would like allow us to see if it's worth it moving on with with a data set, or like starting all over, or it's just like a visual thing that we do?
Yeah, so you're saying like maybe there's sometimes like, oh, is it better to me to drop it, or maybe we can do something like maybe instead of dropping it, we can actually change it to a different value. Is that what you're saying, Lily?
No, I was saying if the data came from somewhere, right? From a survey, from we collected it from a website or whatever source we got the data from, right? Mm-hmm. At this stage where we are, making a decision of just dropping the rows or just starting from scratch, mm-hmm. Is there a tool that we use? Because I know, like I use SPSS and SAS a lot, and the software by itself ignores the missing values automatically, mm-hmm. for you,
right.
Way of dealing. But I don't know if Python or if something that you visually have to come to a conclusion of what to do with the data, whether throw it away or use it.
Yeah, you basically Python, when we're doing stuff, we're kind of in a lot of ways doing the things that like, oh, it's automatically ignored. We're kind of building that ourselves in a lot of ways. We're saying, oh, what should we do? And we're getting a very granular, it's like, okay, we have the raw data, we call it. Like it's raw, it's not cooked, like it's basically all set for us. We can see every little aspect, and we might not want to ignore the things. You can, for example, just do drop NA or basically do .fill NA. So you ignore it more or less and do that. It's not usually something we'd want to do for a lot of things. Usually that data is kind of important, so we actually want to keep that. And also know if you get rid of, let's say, null values, like in the survey, that actually could be important information. That could be like, why did so many people skip over this question? This might actually have been a really important part. I realize I'm close on time, but one kind of aspect, just to kind of give you guys maybe one last thing before I leave then, is, for example, the 2020 elections coming out, or not 2020 census is coming through. So every 10 years in the US, we do our census. Well, there's been a huge debate about what exactly should be in that census. And there's one particular question in there that they're really debating about what we should do. And one of it is basically, do you put in, there's a question that they want to put in where it asks, are you an illegal immigrant? Now, it's supposed to be like, they're not going to go like, if you say yes, they're going to immediately go storm your house if you're an illegal immigrant. But if now all of a sudden that's something you skip over, that might actually give a lot of reasons for people not wanting to actually answer that question or give lies and stuff like that. And this is where like that one question can actually frame a lot of the rest of the data too. So you can have this all the time in surveys and stuff like that. So a lot of times I could say missing data is in fact data. So I like to say the data are data, like whatever it is, like that's important stuff. So you have to decide as a human being, as a data scientist, say, what is important, what do we do? Okay, I do have to go in a second. I'm gonna give you guys one more minute for me to just show like a couple things. Again, this is all in the repo that I shared out at the beginning on the Zoom. But other things you can do is basically replace the values. So you can do a fill NA. So basically say, all right, fill it out with the median or the mean, depending on like what makes more sense for your situation, could be even the mode. You can also just keep it and make its own category saying was missing. So that if that was an important aspect, you might make that row and say, okay, I'm going to fill it in or whatever, but I'm going to say was missing as a separate column. So that way there's an extra actual information. You can also bin it to say like, oh, these are all the missing values over on the side. And then in here, I also have some extra code just to show you, like, for example, if I do df as is NA, you can quickly see true or false. And this is where you can basically see all the different null values, and you can actually sum it up by each part. So this can be useful too. And again, this stuff is shown in the curriculum. All right, everyone. I'm going to stop recording here if you guys are all good.